Hey, thanks for watching this video. There's more at Embark Online. You can tweet me, and there is the Pie Guy. All right, this is third grade, Module 7, Lesson 21, and in this lesson we continue what we did in the previous lesson, Lesson 20, where students are constructing a bunch of different rectangles, all with a given perimeter. So let's get started. Let's remember, though, what are we talking about with perimeter? So when we're talking about perimeter, right here, if we were saying a perimeter of 18, so we're saying that the rectangle, right here, now because perimeter is equal to 2 times the length plus the width, basically what we're saying is, we're saying if you take the length here and the width here, and we're going to call this the length and this is the width. And if you double it, you get the perimeter because over here is another. So they kind of look like sevens or something like that. So you get this, right? So that's why we have to times by 2. You add the length and the width together. That gives you the red part. Then you have to multiply by 2, and that gives you the whole entire perimeter. All right, the distance around the shape. So in this case, we know if the perimeter is 18, that means the length plus the width has to equal 9, because 18 divided by 2 equals 9. So that means the length plus the width has to equal 9. So a way we could think of that is we can make it into a table. And we could say, well, what kinds of combinations of length and width will add together to give us 9? And we can just kind of rattle off a quick list. 1 and 8 gives us like a half perimeter of 9. 2 and 7, 3 and 6. And then 4 and 5. And that wraps them up because after that we start to duplicate previous entries in our list just swapped around. Like 5 and 4 is the same thing as 4 and 5, or 8 and 1 is the same thing as 1 and 8. So in this case, we just quickly made a table of all of the different combinations of length and width that when you add them together you get 9, knowing that if you double it you get 18, which is the perimeter we wanted. So in this case, there are 4 possible rectangles that can be built. So here we're going to do more of the same. The big difference is they want us to record the rectangles that we create on this grid. So it says Margot finds as many rectangles as she can with a perimeter of 14. All right, so there's our perimeter of 14 centimeters. So we know that if we have a rectangle, and I'm just going to kind of draw a rectangle right here, we know that the length plus the width has to equal 7 because the other length and width is also 7 because that's how we're going to get 14, because 7 plus 7 is 14. So since 14 divided by 2 equals 7, that means we know our length plus the width has to equal 7 in order to give us the right perimeter of 14. So what are some combinations of length plus width that would give us 7? Well, we could say 1 plus 6 gives us 7. We could say 2 plus 5 gives us 7. We could say 3 plus 4 equals 7, and that's it. Because if you notice a pattern here, 1, 2, 3, 6, 5, 4. So according to the pattern, 1, 2, 3, the next number would be 4. And according to this pattern, 6, 5, 4, 3, the next number would be 3. But we already have that. That's the same thing as 3 and 4 right here. So we don't need this last entry. Turns out there's only 3 rectangles possible. A 1 by 6. Let's see, a 2 by 5. And then lastly, 3 by 4. So we have a 1 by 6, a 2 by 5, and a 3 by 4. And that are all the rectangles that are possible. Now, while we're at it, we could figure out the area. What's the area of this guy? Well, the area of that guy is 6 units, square units. The area of this guy is 10 square units. And the area of this guy is 12 square units. So even though all three of them have a perimeter of 14 units, perimeter is 14 units, perimeter is equal to 14 units. So even though they all have the exact same perimeter, which is the distance around the block, they all have the same perimeter, but they all have different areas. Very interesting. So here we have Tanner. He's using unit squares to build rectangles that have a perimeter of 18. Now there's the key thing. The perimeter is 18. He creates a chart to record his findings. So remember, if we have a rectangle that is supposed to have a perimeter of 18, that means the length plus the width has to equal 9, because the other length plus width is also 9, and that's how we're going to get a perimeter of 18. So we've got 18 divided by 2 is 9. So that tells us the length plus the width has to equal 9. All right, the length plus the width has to equal 9. Length plus width. So what are all the combinations? Well, you could do 1 and 8. That gives us 9. We could do 2 and 7. That gives us 9. We could do 9. We could do 3 and 6. That gives us kind of like that half perimeter of 9. What else could we do? We could do 4 and 5. 4 and 5 gives us that kind of like that half perimeter of 9. And we've run out of ideas. We've run out of options. There's only 4 of them, because after that we're going to start repeating ourselves. So there's all of our possible combinations, and really I could put them over here. 2 and 7, 3 and 6, 4 and 5, and that last one is not needed. So here's the trick. They want us to find the area of these rectangles. And you remember what area is. Area is length times width. It's the number of squares inside that figure. All right? It's the number of squares, so you're going to multiply. So here, 1 by 8 is 8 square units. 2 by 7 gives us 14 square units. 3 by 6 gives us 18 square units. And lastly, 4 by 5 gives us 20 square units. So even though all of these rectangles have the exact same perimeter, they don't have the exact same area. And the last problem here. It says Jason and Dina both draw rectangles with perimeters of 12 centimeters, but the rectangles have different areas. Explain how this is possible. So Jason and Dina, they both draw a rectangle, and both rectangles have a perimeter of 12. So remember what that means. That means Jason's rectangle, the length plus the width, and the length plus the width adds up to 12. So this length plus width adds up to 6, and then this length plus width adds up to 6, and that's how we get 12. Same thing with Dina over here. So Dina could be length and width adds up to 6, and then the other length and width also adds up to 6. So let's come up with a couple of combinations, one for Jason, one for Dina. So what's a combination of length and width that adds up to 6? Well, we could say 2 and 4 gives us 6. How about for Dina? Well, Dina could be 1 and 5. So we could say for Dina, it's 1 and 5. Now we're supposed to figure out the different areas. What are the areas of these two rectangles? Well, we definitely know the perimeters are both 12 centimeters, but what's the area? Well, remember, area is length times width. So for Jason, that's going to be 2 times 4, which is 8 square units. And sure enough, if we were to draw it, there's our 8. You can see our 8 square units. 1, 2, 3, 4, 5, 6, 7, 8. For Dina, if we wanted to find the area of her rectangle, that's going to be area is equal to length times width, which in this case it's 1 times 5, which is 5. So that's 5 square units. Yeah, that's right. And so how is this possible? Well, it's possible because Jason's is a little bit more compact and Dina's is a little bit more stretched out. So they use the same perimeter, but they have different areas, and Jason's has a greater area because his was more compact, more like I guess like a square. All right. And that wraps up a fun one. That was 3rd grade, Module 7, Lesson 21. Students are constructing a whole bunch of rectangles with a given perimeter.